In this video, I'm going to go over a few examples that help illustrate how we can use trig functions. This first one says to solve the triangle. Now, what that means is when we say solve the triangle, that just means find all missing sides and angles. Oops. And angles. So what we need to know is we need to figure out side A, side B. We need to solve for this angle beta. Okay, so there's always 6 parts in a triangle that we would want to solve or be able to identify. 3 angles and 3 sides. We already have 2 of the angles and 1 of the sides, so we need the other 2 sides and the missing angle. So the best way to do this if you're doing this by hand and it's going to be graded, is to just write out everything kind of off to the side, the things we know, and then we'll fill in the missing pieces. So alpha, beta, let's call that side that's 6, let's call that C, or angle C, and then we'll say A, B, and C. And remember, we use lowercase letters for sides, and we use either capital letters or oftentimes Greek letters for the angles. So we already know that angle beta, or we know angle alpha is 30 degrees. Okay, and we know that 30 is alpha because it's opposite of side A. So alpha and A would be going together. Side C is going to be 6. Angle C is this right angle, so that's going to be 90 degrees. Alright, so we want to find side A and B and then angle beta. Now angle beta is going to be easy because all of the angles in a right triangle, or not just a right triangle, but any triangle, the angles add up to 180 degrees. So if I have 30 and 90 already, we know that what's left over is 60 degrees. Alright, and because we have a right triangle, we can use some right triangle trig to find these 2 missing sides. So let's go ahead and find, side A first. So side A, side A is opposite this angle, 30 degrees, and then we have the hypotenuse. So we could use sine here, so sine of 30 degrees is equal to the opposite side divided by the hypotenuse. So to solve for A, I multiply both sides by 6. We get 6 times sine of 30 degrees is equal to A. Alright, so at this point, we'd use a calculator, and we'd type this into the calculator first, sine of 30 degrees. We'd hit enter, and we'd find out that that is equal to 0.5. So 6 times 0.5 is equal to A. 6 times 0.5 is 3. So 3 is equal to A here. Now, if you've never done anything like this on a calculator, there's a couple things to keep in mind. Remember, the input for a sine function is an angle. We can write angles in degrees or radians. So when we're doing that, we need to make sure that the calculator is in the correct mode. So the calculator has both degree and radian modes. So obviously, well, maybe it's not obvious, but if your calculator was set to radian mode and you had entered this, that would be interpreting the sine of 30 as sine of 30 radians, and we would have gotten something different than 0.5. So we need to remember whatever unit our angle is being measured in, that the calculator is in that mode. This is a very common mistake that students will make, so you need to be extra careful when entering any trig function and making sure that the mode is correct. Okay, so we did sine of 30 and we said a over 6, and we solved for a. We could have chosen a different trig function to figure this out. So this time, why don't we start with angle beta? Now, that's not really, yeah, that'll work. If we want to figure out what side A is going to be. So what we could have done is, well, from angle beta, we have this side. We know it's, hang on one sec. Oh yeah, we're trying to find A. I already have it over here, but we're trying to find A. We could have done A is the adjacent side, 6 is the hypotenuse. So when we have the adjacent and hypotenuse, we could also use cosine of beta, which is 30. Don't need to write that. So cosine of 30. Gosh, I'm losing my mind here. Let me take a deep breath. So cosine beta is 60 degrees. The adjacent side is A. The hypotenuse is 6. So multiply both sides by 6. I get 6 times cosine of 60 degrees is equal to A. All right, so you could punch this in your calculator. Cosine of 60 degrees, you would get 0.5. Similarly, 30 over here and 60 over here are cofunctions of each other. So sine of 30 and cosine of 60 are going to equal the exact same thing. So 6 times 0.5 is equal to A. 3 is equal to A. So I just wanted to show both ways here, just to illustrate that there's not always just a single trig function that we could have used. All right, so A is 3. To find out side B, there's a couple ways you can do it. Probably the easiest way is to just use the Pythagorean Theorem. A squared plus B squared is equal to C squared. So this is 3 squared plus B squared. C squared is 6 squared. So we have 9 plus B squared is equal to 36. B squared is equal to 27. So you could say the square root of 27 is equal to B. If you reduce that, this is equal to the square root of 9 times 3. 9 is a perfect square, so we take the square root of 9, which is 3, and we end up with 3 root 3. So when we're solving a triangle, it's nice to summarize everything just like this as the answer. All right, our next example says, to find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures an angle of 57 degrees between a line of sight to the top of the tree and the ground, as shown. Find the height of the tree. Okay, so we're trying to figure out what the height is here. So we can see that this forms a right triangle. If we're kind of orienting ourselves at the 57 degrees, this height is the opposite side of that angle, and then 30 feet is the adjacent side. So we need to use the trig function that uses the opposite side of the angle and the adjacent side. Tangent does this, so tangent of some angle is equal to the opposite over the adjacent side. Cotangent also uses these two sides, just the reciprocal of tangent. However, we're going to use the tangent function because the tangent function is going to be on the calculator and cotangent is not. So typically we want to use either sine, cosine, or tangent for questions like this. Okay, so remember, inside the trig function always goes the angle. All right, the opposite side is what we're trying to find. I'll just call it y here. And then the adjacent side is 30 feet. So multiplying both sides by 30 isolates the y, so we get 30 times tangent of 57 degrees. So you're going to need to punch this into the calculator. Remember, make sure you use degree mode here because this angle, 57 degrees, is in degrees. You probably had the calculator already in degrees from the previous question. but it's good to check that. So punching in tangent of 57 degrees into the calculator, and then multiplying by 30, you can actually just write or enter all of this at once into the calculator, and we end up with about 14.54 feet for the height of the tree. And that's it. All right, last example here. A support wire of length 108 meters runs from the top of an antenna to the ground. If the angle of elevation to the top of the antenna is 42.3 degrees, what is the height of the antenna? So we're trying to figure out this value y. So as you're thinking about this, we need to locate our angle, 42.3 degrees, and consider the sides of this right triangle, that the information we have and what we're trying to find. So we want to find this length, which is the opposite side, and we have the hypotenuse. So the trig function that takes into account the opposite side and the hypotenuse is the sine function. So we're going to say sine of the angle, we always put the angle inside the trig function, is equal to the opposite side divided by the hypotenuse. So multiply both sides by 108, and that will isolate the y. 108 times sine of 42.3 degrees. So again, we can enter this all into the calculator. Make sure you're in degree mode, and doing so we end up with about 72.685, what's our unit, meters here, and that would be the height of the antenna. Alright, I want to just mention one thing about this expression, or I should say previous to that. When we're at this step and we multiply both sides by 108, a common mistake that students make is they say, oh, sine of 42.3 degrees times 108 is equal to y. Okay? Now we don't want to do that, because this expression, sine of 42.3 degrees, those two things are going together, and nothing else is going to enter into the input here aside from the 42.3 degrees. So when we multiply by 108, we want to be multiplying by this entire expression, not inside the input of the function. 108 does not become the input of the function in any way. So we do not want to do this. So be careful to not do something like that.